Good morning, everyone. In the today's class of this operational research, we would like to proceed regarding the arithmetic and graphical methods, or the B methods, which are being utilized in the case of this game theory problem solving in operational research for getting the optimum solution. So, we already learned regarding the mathematical models, mathematical method of solving the game theory. In the today's class, we would like to move regarding the other topics which are utilized indeed to solve the different types of game theory problems. Initially, moving on with respect to this arithmetic method, the arithmetic method is also known as the cut method, which is very much easy to find the optimal strategies for each and every player in a payoff matrix as of the size 2 by 2, and that too without the saddle points. So without saddle point, in the sense we have seen a clear cut vision in the solvation of this payoff matrix that the tie between this player 1 and player 2 leads to a saddle point, nothing but the equating in the results or reminding strategies upon the additional or a similar number that is being existing in the rows and the columns. So that leads to a form of this saddle point. So even not only this 2 by 2 of payoff matrix can be increasing furtherly also towards 4 by 2, 4 by 4, and even rather than incrementing than the 2 by 2 matrix. Let's have a detailed discussion regarding the different steps utilized to solve the problems in the case of this arithmetic method without getting a saddle point. So that leads to an immediate result generation. So if the saddle point occurred in the way of this payoff matrix, you cannot justify that player 1 is in a win condition or else player 2 is in win condition. So you need to specify for the winning condition to either of the players, that maybe of the two players or maybe can be increased furtherly the players list also. So as if now we are considering this player 1 and player 2. Let's look after the stepwise methodology in the case of solving this arithmetic method. Primarily, in the step 1, finding the differences between the two values in the first row and put it against the second row of the matrix without any significance with respect to the negative value. So even if the negative values are obtained, we'll be just discarding it. In the step number 2, the differences between two values in the second row and put it in the against the first row of the matrix, neglecting the negative signs if any that is being occurring. Simultaneously, repeating the similar steps in the case of these columns also. We'll be looking detailedly how the crossing is being getting taken place. The value obtained by swapping the difference represents the optimal relative frequency of play for both the players' strategies. So nothing but the efficiency or else that swapping difference. So almost the values which have been obtained in the case of row 1 is allocated in the row 2, and values in the row 2 which has been came, the difference will be allocating in the row number 1, and the value which is obtained by swapping the difference, nothing but the difference values which are obtained at the categorizations, nothing but based upon the difference here, as we have been taking the minus difference, will be calculated furtherly, and these calculated values represents the optimal relative frequency for both the players and their strategies. And even these may be converted to the probabilities by dividing each of them by their sum. In what way the steps has been commenced, practically we'll be having a detailed look over here. So initial condition is no saddle point is allowed. So no saddle point in below payoff matrix. So considering 2 by 2 matrix, that is regarding the rows, player A, and regarding the columns, player B has been allocated. A1 is the row number 1, A2 is the row number 2, and B1 column number 1, B2 column number 2. Here, regarding the rows, we'll be having a detailed discussion. And regarding columns, the differences has been calculated and division has been mentioned over here. Considering with respect to an first condition, that is swapping system. So first condition, it is nothing but differences, finding the differences between two values in the first row and put it against the second row in the matrix, neglecting with respect to the signs. So considering the first row, first condition, that is minus 1, and hence with respect to minus, that will be allocated towards the minus 1. So second row will be allocated in the first row, and first row will be swapped to the second row. So here the values are a1 related to difference minus of, so minus 1, so minus into minus plus 2 plus 1, it is the 3 value. And the second one, it is, so second row a2 value, so a2 value will be swapped over the a1 row, and hence minus 1 minus difference 0 relates to the minus 1. And hence next, the second point, it is finding the difference between two values of the second row will be put against the first row. It has also been assigned. And third one, the step, it is obtained optimal relative strategies will be converted to the probabilities by dividing each of them by their sum. So division with respect to their sum. So how it will be indicating will be energizing over here. Nothing but here initial strategy, it is 1 by 1 plus 3. Relation of the characterizations. So here the nominal values, even the negative sign is neglected, that has been came into the existence. So even the negative value has been existence, will be discarding the values. So the signature is not at all mandatory for us. Hence, even though it is positive or negative, we'll be considering it as a positive. And hence, the obtained optimal value divided by the total values without any negative constraints. And hence, we'll be obtaining this value as an 1, first one, 1 by 1, obtained value 1 plus another row 2, obtained value is 3. So 1 by 1 plus 3, that is 1 by 4. That is the condition. So we'll be taking only these optimal values. So optimal value for row 1 from the swapping of row 2 is 1, and that 1 is the basic value in the case of row 1. And next, row 1 optimal value plus row 2 optimal value, that is 1 plus 3. Simultaneously here have a look regarding the a2 also. So optimal value of a2 upon swapping with respect to the a1, the value that is obtained for a2 is 3. So 3 by 1 plus 3. So here minus, so discard about the minus. There is no any specifications related towards the signatures. So even the negative signature, we will be neglecting it. That is, has been clearly specified here. That is neglecting the negative signature. Is there, if any, right? Negative signature అనగానే మనం omit చేయాలి. And beyond that, we will be obtaining the values of 3 by 4. And hence, there will be an 1 by 4 plus 3 by 4. The probability of statistics is 1. So any one of the player will be getting into the win category. Simultaneously, we will be having a relation towards the player B also. So here, player B, first one, B1 will be allocated its difference and entering into the B2 row of signature. Simultaneously, B2 to the B1. So let's have a detailed look towards the B1. So 2 minus of minus 1, that is 3 is the value. And here B2, that is minus 1, minus 0, that is minus 1 is the value. And similar strategies obtained optimal values divided by the addition or sum of the optimal values. That is first one, 1 upon swapping for the b1, so 1 by 1 plus 3, 1 by 4. Simultaneously for b2 it is 3, 3 by 1 plus 3, that is 3 by 4. So similar values has been obtained for both the a1 a2 and for player b also, that is b1 and b2. So considering the uh, A's as an odd means in the sense outstanding or negative approachments. Then by that we'll be having only the players regarding the B side section. Odds in the sense nothing but winners are allocated towards the player B in the sense. So what will be the dedication? So hence odds will be A statement and considering only the player sides of B. So player B plays B1 and hence this B strategies dedicates towards A elements, that is nothing but multiplication factor for both the rows contents. Nothing one will be utilizing A's as an coefficients, odd means and sense coefficients, and that coefficients will be multiplied with respect to the optimal generated values, and hence we'll be relating the values overallly with respect to the condition, and we'll be having a detailed look, that is 2 into the obtained row 1 value, that is 1 by 4, and hence 2 into 1 by 4 plus the coefficient of a1, that is minus 1, a2, sorry a1 second coefficient, that is minus 1 into the second answer or optimal value is 3 by 4, so minus 1 by 3 by 4, and hence 2 by 4, that is 1 by 2 plus minus 3 by 4, that leads to the minus 1 by 4 of answer. And simultaneously regarding the B player also, that is minus 1 is the odd element of the A, minus 1 into 1 by 4 is the answer, plus next 0, 0 into this 3 by 4. So 0 into anything it is 0, and hence minus 1 into 1 by 4 leads to minus 1 by 4. That is the, if we have been assumed these odd elements of A. Simultaneously, if we have been assumed these B elements as an odd elements, then we'll be multiplying or we'll be taking these coefficient values as an B, and A's terminologies will be specified. But here in the answer, if you have been observed clearly, the optimal values for both the rows A1 and A2 is simultaneously equal to the columns B1 and B2. So A1 row it is 1 by 4, B1 row it is B1 column, that is 1 by 4. So A2 row, that is 3 by 4, B2 column, that is 3 by 4. Similar values, and hence here the coefficients will be getting changed. So 2 minus 1, 2 minus 1, and minus 1, 0, minus 1, 0. So same values will be approached over here also. So minus 1 by 4, minus 1 by 4. So hence even when you have been considered A oddments also, the results are minus 1 by 4, and even when you have been considered these these elements also, the final values regarding the player a1 and player a2 is also minus 1 by 4 and minus 1 by 4. Therefore, as per the decision taking place towards the player a is nothing but 1 by 4 comma 3 by 4, those are the optimal values generated, and player b also existing the similar values 1 by 4 and 3 by 4 upon swapping and division with respect to an obtained values. These are the values a1 and a2, and these are the b1 and b2 optimal values. So those are the optimal strategy of player a and simultaneously the player b. And what's the value of the game here? So value in the sense upon taking the oddments, nothing but oddment in the nothing but the coefficient taking towards the next player's efficiency or next player's optimal values, summation of next player's optimal values, and it leads to the value of the game. So hence the value of the game has been specified with respect to minus 1 by 4. So this is the methodology of solving the problems towards this. arithmetic method, that too without any saddle points. If the saddle points has been obtained, then it doesn't suit for finding the optimal values in the case of this mixed strategy. So mixed strategy in the sense leads that to two categories, with the saddle point and without the saddle point. So with the saddle point, you cannot generate the optimal values, and hence with no saddle points without generating towards this saddle points, then only leads to form the odd by the implications of this oddments towards this player A and player B leads to generate the optimal values or optimal strategies for the players A and player sides B, and can generate the value of the game. Going on to the graphical method, the graphical method is useful for game where the payoff matrix is of the size 2 by n or m by 2. Nothing but it is mixed strategies having two undominated pure strategies for one of the player in two players, that is raised towards the zero sum game. So zero sum game in the sense relates towards the no value, and how the steps or solvation procedure need to be allocated in the case of this graphical method will be having a detailed stepwise look here. First one, step number one, as this a 2 by 3 matrix does not have, this is a 2 by 3 matrix having two rows, columns has been extended towards the 4. If if 2 by 3 matrix does not have the saddle point, therefore graphic method is to be used to reduce it to the 2 by 2 game, and hence it has to be minuted to the 2 by 2 game. As in the arithmetic method also, we have been clearly shorted that 2 by 2 matrix is suited for solving, and we all aware that without leading towards the saddle point, only the 2 by 2 matrix is plays a major role. And hence, if at all additional matrix given to us in the problems, we have to decrease it upon addition and swapping, addition and subtracting, sorry, addition and subtracting, and minuting the problem to 2 by 2 matrix with the new additional optimal points generating. So that is the first step. If here in the graphical method clearly specified that the size of the matrix is nothing but 2 by n or the m by 2, nothing but both in the case of these rows and as well as these columns, then which doesn't have the saddle point, that is nothing but the matrix need to be generated which doesn't have the saddle point have to be reduced to the 2 by 2 game. And for that reduction, what are the steps not to be taken? So that has been specified in the step number 2, that p1 and p2 be the probabilities with which player A uses his pure strategies, nothing but the expected payoff of player A corresponding to player B's pure strategies are specified in the general table or column. So considering a simple example, player A is having two rows, and the probability of solving towards this player B, playing towards the player B is P1 and P2, that has been indicated towards here. Those are the pure strategies, and paying off a matrix generated towards this player B, that is B1, B2, B3, and B4. Moving on with respect to the allocation of this player B strategies, what are the expected payoff matrix we will be having a detailed look. We'll be generating 2 by 2 with respect to a corresponding coefficients or nothing but the strategies, probabilities of strategies as per the given question. We'll be having a detailed look. So comparing the B side players as a pure strategy, we'll be finding out the B side players as a pure strategy. First one B1 relates to column number 1, column number 2, column number 3, and column number 4. So having the two similar or non-similar or dissimilar values, and indeed to generate the possible number of ways, the probability has been specified with respect to the P1 and P2 in the case of A's payoff matrix. So what is the payoff matrix towards the A will be generating, will be having a arithmetic towards the arithmetic solving of problems. So comparing the B's as and pure strategies need to find. Moving on with respect to the V1, that is column number 1, that is 2 strategy, n number of possible ways towards the A1 player, it is 2P1 plus 4P2. Nominally regarding the B2, 2P1 plus 3P2. Regarding this B3, column number 3, that is 3P1 plus 2P2. Column number 4, that is minus 2P1 plus 6P2. So those are expected payoff matrix, but they may not be have the similar values, or upon solving they may be having a difference in calculations. So for that we'll be taking an graphical synonym here. So this graphical synonym will clearly specifies the characterizations towards the possibility 1 and possibility 2. So we'll be having this graph. So there is three expected payoff lines are plotted on the graph to solve the problems that we'll be having a vision here. So graph for player A. Draw the two parallel lines apart from each other and mark the scale on each as shown here. And these two represent the two strategies of player A, and hence the graph is nothing but solvation towards the maximum condition or towards the minimax conditions. So maximum condition in the sense max that specifies the positivity, that is above the zero, and it is a nominal zero indication lines. So below minimax in the sense negativity will be placing role, but negativity is being distracted in our conditions. So we'll be having a detailed look towards the strategy that from this condition B1 condition 2 to 4. So considering this is an V1 and this is an A1, sorry, A1 and A2 conditions, and crossing out with respect to the B1 strategy with respect to two opposite, that is nothing but expected P of sessions B1 coefficients with the probability ranges from P1 to P2, P1, P2 with corresponding to the A1 and A2 or the values 2 and 4. And hence from initially it is 2 and 2 to the first condition it is 4. We have drawn a line, and simultaneously in the second strategy B2 2 to 3, and hence the point is a green line that is starting from point number 2 to point number 3. Simultaneously the value of 3 to 2 and decreasing in strategy, so point number 3 to, and hence the value of 2, right? And fourth one it is minus 2 to 6. So here minus 2, some slight deviation occurred in the graph while I am drawing. So minus 2 to 6, consider it as a 6. Hence these are the points that need to be remembered in the case of this graphical method. So now identifying the limitations within the graphical representation. So first one it is 2 to 4. Next one simultaneously from 2 to 3 is the value green color, and this thick red color indicates from 4 to 2, and next one minus 2 to 6. All right. So from the graph, the payoff matrix will be reduced, and by utilizing this arithmetic matrix, we can solve the problem. So arithmetic matrix in the sense we are all aware that taking the difference calculations and swapping the B3 value to B4 and B4 to the B3 values, and division with respect to the obtained values, multiplication with respect to the base value to the sum of the values that are being obtained. So we'll be having this player A1 and A2, considering B3 and B4 are the optimal values that are being existing in the case of this 2 by 2 generation. So 2 by 2 generation, there is minimum condition it is 3 and maximum 3 minus 2 and 2 6. So condition 3 minus 2 and 2 and 6 as a B3 and B4. Because why you have been chosen only this B3 and B4? So third one and fourth condition. So minus 2 onwards, you have been considered the maximum of 6. The dome line is being existing. Next one is 3 to 2. So range of maximum towards the B1 category, the player A category is this one. And minimum range of is minimum range in the case of this player 2 in the case of this A kind is 2 in the positivity. And hence remaining values are within the limitations. So remaining values are within the limitations. So beyond the 4, it is being existing 3 value. So nominally beyond the 6, remaining values are existing. So outermost points we are being specifying outermost values. So that is 4 minus 2, and next is 6, and next this is 2 value. So outermost dome line values, values we are being taking. So that border lines we are having with respect to this B3 and B4. That is 3 and minimum 2 and minus 2 and 6. So next B1 and B2 values are existing within the B3 and B4 limitations. So that is the condition we are choosing B3 and B4. So అది మనకి ఎలా తెలుస్తుందండి, when you have been drawn the graphical representation, then only we'll be having a detailed look. So minus 2. So here 3 is existing in between minus 2 and 4 plus 4. So in between it is existing. So outer border points are 4 and next is minus 1. Simultaneously towards this player A2 also similar. The 6 is the major point in the case of this player A2 and 2 is the minimum point. And remaining 3 and 4 values are existing in between this 2 and 6. So border points are 6 and next here it is 2. So that's why we are taking this B3 and B4. That is the reason we are considering only this B3 and B4. And next arithmetic calculations, we are aware that difference of the calculations and swapping that value to the next column. So 3 minus 2, that is 1, and here minus 2 minus 6, that is 8, right? So 8 that we are considering without having considering the negative values, and hence this minus will be discarded because we will be omitting this minus value. Hence 2 plus 6 leads towards the 8. And we all aware that basic obtained value with respect to an summation of the values division leads to an optimal value, that is 8 by 8 plus 1, that is 9, and here 1 by 8 plus 1, that is 9. Simultaneously towards the rows also. So here it is 3 plus 2, 3 minus of minus 2, that is 5. Simultaneously 2 plus 2 minus 6, that is 4 here, that is 2 minus 6, that is minus 4 nominally, and minus will be discarding. Commonly here also minus 2 minus 6, that is minus 8. We are discarding the negative sign. That is the condition. So here also minus will be discarding 4, and hence the obtained value upon swapping divided by the summation of the values is leads towards the optimal value. That is considering this row 1 4 by 5 plus 4, that is 9, and hence this 5 by 4 plus 5, that is 9, 5 by 9. Hence the optimal values regarding this row 1 is 4 by 9, row 2 is 5 by 9, column number 1 is 8 by 9, and next column number 2 is, that is 1 by 9. And hence values of the game, that is nothing but towards, if the odd strategy has been taken towards A, that is 3 into 4 by 9 and plus 2, sorry, minus difference, minus into minus 2 into 5 by 9. So minus into minus plus 2 into 5 by 9. That's equal to 22 by 9. And simultaneously have been calculated towards this also 3 into 8 by 9 minus 2 into 1 by 9, and plus of minus 2 into 8 by 9 and 6 minus of 6 into 1 by 9. So these will be the values, and hence the obtained value or any one of the value will be leading towards this 22 by 9. Indeed, to summate these value or else indeed to summate these value will be equal in strategy. So how we will be justifying this? So calculate this value 8 by 9 plus 1 by 9. So the LCM is 9, 8 plus 1, that is 9 by 9, that is equal to 1 value, unity value. And here also 4 by 9 plus 5 by 9. So LCM it is 9 and 4 plus 5, that is 9, 9 by 9 is equal to 1. So here also 1 value, here also 1 value. And hence upon implication factor by taking the ardent category towards the A or towards the B leads to the similar value. That is the reason. So hence the optimal strategies are 4 by 9, 5 by 9 towards the A, and here it is 0 and 0 for two cases, that is B1 and B2, and B3 and B4, that is 8 by 9 and 1 by 9. And the value of the game it is 22 by 9. So application of this graphical method leads to identify the 2 by 2 matrix. So that is within the limits. So that is the graphical method of solving the conditions. And hence going on to the significance, this creates the graphical method or quantitative technique will be calling gives a clear cut frame cut look to analyze and identify this 2 by 2 matrix in a simply way, and generating the value of that is interdepending on the firms about the competitors reaction also. Hence the course which has been adopted by the firm provides the specific quantitative technique even, which gives an fruitful values simultaneously. And those are the positivities having there is advantages. And coming to the limitations of this solving, the assumptions of the player and will have a knowledge about their own payoff and payoff matrix generation that will be unrealistic. Only we are assuming the values, but these are not equal. We are only guessing the values. And minimax and maximin numbers of gaming structures becomes increasingly complex and very much difficult indeed to identify. And many of the oligopoly situations, nothing but unity, that is nothing but will be helpful for solving that unification of values, very helpful in such situations. And it leads towards the risk averse and have a complete knowledge in the strategies, don't have a practical situations. All right, we'll be solving the problems related towards this minimization of 2 by 2 matrix upon the m and n rows and columns in the next class. Thank you.